Hello everyone, welcome to Math with Allison. Today we're continuing our series on limits. If you haven't already, make sure to check out some of my previous videos here. Click that little eye in the corner, it'll get you there. Otherwise, we're doing challenge problems today. So here they are all laid out for you. If you want to skip to a particular problem that you're interested in, you totally can do that, but I'm just going to go ahead and work through these. So pause it if you need it. Otherwise, I'm moving on. So let's go ahead and take a look at problem 1 here. I'm going to zoom in a bit. So we are wanting to evaluate this limit, but we have an issue, right? If I were to use direct substitution and I plug this in, I would get the square root of 4 minus 2, which is equal to 0. And that's our issue. We can't divide by 0. So actually what we need to do instead is we need to multiply by the conjugate of the denominator. So our conjugate is where we keep the same terms. So we have a square root of x and we have a 2, but we switch the sign in between. So this becomes a plus. Now I can't just multiply out of thin air. I also have to multiply the numerator by that same thing, because then it's like I'm multiplying by a giant 1, and that is legal to do. So I'm going to go ahead and multiply this out. When I multiply the denominator, I get the square root of x times the square root of x is equal to a normal x. Those exponents add up, we get 1/2 plus 1/2. So I'm going to continue multiplying out. So I get plus 2 times the square root of x minus 2 times the square root of x plus minus 4. And so now I can see that those middle terms, they cancel out nicely, which is the point of multiplying by the conjugate. So now what I get in the middle, or in the denominator, is x minus 4. Typically what we want is that this term divides out. And as we can see, it doesn't quite divide out yet. Always try to factor it as much as possible. Because what if I took a 2 out of that first term? Now we have a difference of cubes. And I can actually simplify this out a bit. I'm going to go ahead and do that. Now I can see that that term, our issue term, divides out, right? So that x minus 4 divides out, and this is what I'm left with. Now I can go ahead and use direct substitution. So when I plug that in, I get 2. 4 squared is equal to 16, minus 4 times 4, which is 16, plus 16, times the square root of 4 plus 2 is just equal to 4. So 16 minus 16 is equal to 0. So I get 2. 16 times 4 is 64, which is equal to 128. So my entire limit is equal to 128. And that's our solution. Let's go ahead and move on to the next problem. So here we want to find the value of k where the limit is defined. So I want this limit to exist. That usually means that there's an issue value, and I want to go ahead and see what my issue value is. So if I use direct substitution and I plug that into the denominator, I get 2 times 3 squared minus 5 times 3 minus 3. Simplifying this out, I get 2 times 3 squared is 2 times 9, which is 18, minus 15 minus 3, which is equal to 0. So I can see I have an issue with the denominator, it goes to 0. So first what I'm going to try to do is factor. The numerator looks kind of fishy because I have that k, so I'm going to leave it as it is. And I'm going to go ahead and factor the denominator. Now I can see more clearly, really x minus 3, that's our big issue. This is the term that's going to go to 0 and make a 0 in the denominator. So just like in the previous problem, what I want is this term to divide out. But we're working with a k here, not actual values. So I'm going to go ahead and do long division, everybody's favorite, to see how I can make this divide nicely. So I want x minus 3 to divide into the numerator. 4x squared plus kx plus 7k minus 6. So if we remember long division, I need a term right here that multiplies by x in order to get 4x squared. So I'm going to go ahead and multiply it by 4x. When I multiply 4x by our terms, don't forget we have to multiply 4x by the whole thing, and that's what I'm subtracting. So here I get 4x squared and minus 12x. But again, like I said, we are subtracting this whole thing. So I get the first terms cancel out. This becomes a plus, and I get 12x plus kx. And now I'm going to bring down our next terms, plus 7k minus 6. I'm going to go ahead and regroup these a little nicer. So I know this becomes 12 plus k times x plus 7k minus 6. So now I need another term that I'm going to write right here that multiplies by x minus 3 in order to get 12 plus kx. And this term is actually just going to be plus 12 plus k. It's going to be that whole term. So when I multiply that through, I get 12 plus kx, which is what we're looking for. And now I need to multiply that whole thing by negative 3. So that gives me negative 36 minus 3k. And remember, I'm subtracting this entire thing. So first, these guys cancel out, which is exactly what we want. And now I'm going to go ahead and turn both of these into pluses. So I get 7k plus 3k is equal to 10k. And then 36 minus 6 is equal to 30. So with long division, if it divides nicely, this actually should equal 0. So I'm going to use this to solve for my value of k. I'm going to scroll down a little bit. 10k plus 30 needs to equal 0. So it divides nicely. Subtract over that 30, I get negative 30. And divide both sides by 10, I get k is equal to negative 3. So we have a k value now. I'm going to go ahead and rewrite our limit. I just went ahead and replaced k already in the numerator, but we already know how this is going to factor because of our long division. We have the limit as x approaches 3. We made it so that x minus 3 is a factor, and if I go back up, my other factor is going to be what's written right here, with k equaling negative 3. So if I plug that in, I get 4x plus 12 minus 3 is equal to 4x plus 9. And that gives me my other term. So plugging that in, I get 4x plus 9, all divided by the denominator. And now I can see my issue, which was that x minus 3 divides out. Let me go ahead and rewrite my limit. Now I can go ahead and use direct substitution, right? So I get 4 times 3 plus 9 all over 2 times 3 plus 1. Just doing some algebra, I get 12 plus 9 over 6 plus 1. 12 plus 9 is equal to 21 divided by 7, which is equal to 3. So this tells me that k must equal negative 3 in order for my limit to exist, to be defined. So that's all I got for that problem. Let's go ahead and move on to the next one. We needed to define all values of x where f of x is continuous. So remember, to be continuous, it just means all the values we can plug in aren't illegal. So actually, I'm going to go ahead and look for our illegal values. So I'm going to go ahead and take this first term. I know 1 over x is not defined at x is equal to 0, right? Because we can't divide by 0. So I know 0 is going to be illegal value because 1 over x is not continuous at 0. It actually has an infinite discontinuity because the function goes like this. Beautiful drawing, 10 out of 10. So what I'm also going to look at now is my second term. So again, if I look inside the square root, I have a fraction. So I don't ever want my denominator to equal 0. But is there ever going to be an x value we can plug in to make this 0? If we're not sure, we can try to solve. X squared cannot be equal to negative 1 if I subtract that over. Taking the square root of both sides, I get x cannot be equal to the square root of negative 1. That's already an imaginary number, so we're not going to be dealing with it. So I know my denominator is okay. It's not going to ever equal 0. We also know that our denominator is going to be always greater than 0 as well, because when we square a value, it always turns out positive. We add 1, that's still positive. So we know that our denominator is always going to be positive. The issue with square roots is that we cannot take the square root of a negative number, which means my numerator, x plus 6, must always be greater than or equal to 0. So I'm going to go ahead and solve. I subtract 6 over, I get x is greater than or equal to negative 6. So the values for which my function is always going to be continuous is going to be starting at negative 6, going up to 0. But remember, we can't include 0. So I'm going to use a soft parentheses and I'm going to union it with 0 to infinity. So here we have both conditions met. X equals 0 we're not working with, and x is going to be greater than or equal to 6. So this is going to be all the values for it to function as continuous. Let's go ahead and move on to the next problem. Here for problem 4, we have the limit as x approaches 0 of that whole nonsense. One trick I always suggest we look at is whatever our trig is, because we can always bound our trig functions. Cosine, no matter what's inside the cosine, so in this case we have pi over x, doesn't matter what's in there, cosine of that is always going to be between positive 1 and negative 1. If we think of the graph, it's always hitting those two values but not going above or below it. So I'm going to manipulate it to look like that original function in the limit, which means I'm going to multiply all sides by whatever we want to call that whole thing. So I'm going to go ahead and multiply that in. Now I'm going to go ahead and apply the limit. I can apply using direct substitution the limits on either side of our original function. So when I do that, I get the negative square root of 0 plus 0 cubed. We know that this is equal to 0. Same thing with our other side. I get the square root of 0 plus 0 cubed, which is equal to 0, which tells me my limit has to be bounded between 0. So since it's bounded between 0 on both sides, that means our original limit actually equals 0. And so that's how we would use the squeeze theorem to solve this limit. Let's go ahead and look at our next problem. Problem 5 is we want to find all the values of a, b, and c that make f of x continuous. So remember, in order to be continuous, it has to be perfectly smooth. My pencil is never picked up in order to draw it. So that means the values on the left side and the right side of all of where it's split have to be equal to one another. So how I would write this out as a limit is I would take the limit as x approaches negative 2 from the left side, and I would take the left side of that function. So when x is less than or equal to 2, we have 6 minus 3bx. And I said this has to be equal to the limit as x approaches negative 2 from the right side, and now I take the right side, and that is cx squared minus ax plus 4. So now I can apply the limit. I'm going to just use direct substitution. I get 6 minus 3b times negative 2 is equal to c times negative 2 squared minus a times negative 2 plus 4. I'm going to go ahead and simplify that out a bit. Now I'm going to go ahead and combine like terms. So I have a 6 and a 4. I'm just going to subtract over the 4, so I get 2. Looks like I can take a 2 out of all those terms, so I'm going to divide everything by 2. And actually what I'm going to do is isolate a and get a all by itself. So I'm going to subtract over that 2c. So I get 1 plus 3b minus 2c is equal to a. And I'm going to go ahead and highlight that so I can remember it. Now I have to do the same thing for the next pair. And the next pair is going to be at negative 1. I'm going to go ahead and write that out. And now I can use direct substitution to solve that x value. I'm going to go ahead and simplify. Now I'm going to go ahead and combine like terms. It looks like, again, we just have constants. So I'm going to subtract over the 6, so I get c plus a minus 2 is equal to b. So I'm going to plug in what we had of a from the original problem right here. And I'm going to go ahead and plug that in for my a right here. When I do that, I get c plus 1 plus 3b minus 2c minus 2 is equal to b. Here I'm going to go ahead and combine like terms. So I have that 1 minus 2. That is equal to negative 1. I'm going to look at my c's. I get c minus 2c, which is indeed equal to negative c. And now if I were to subtract this 3b over, I would get this is equal to negative 2b. What I can do here instead is I'm just going to switch this around and make it so I solved for c. So negative 1 plus 2b equals c. And I'm going to go ahead and highlight that as well. So now we have one more split, and this is going to be at x equals 1. So now I need my left limit to equal my right limit. Let me go ahead and write that out. Again, I'm just using direct substitution. So I get 6 minus b is equal to a plus c. And now I can plug in those values that I know. I know c is equal to negative 1 plus 2b, and I also know what a is equal to. So let me go ahead and plug all of those in. I need to plug what c is equal to one more time. And now I have a whole equation all in terms of b. And I can now solve for b, which is going to take a lot of algebra. So first, let me go ahead and simplify this. So I get 6 minus b is equal to 1 plus 3b. And now I'm going to distribute that minus 2. So I get plus 2 minus 4b minus 1 plus 2b. So first I'm going to take my just my numbers. So I get 6, 1, 2, and negative 1. So I'm going to keep that 6 on this side is equal to 1 plus 2 minus 1. So those minus 1s cancel, and I get 2. And now I'm going to combine my b's on this side. So 3b minus 4b is equal to negative b. Negative b plus 2b is equal to positive b. So now I get plus b. I'm going to go ahead and add b to both sides. And I'm also going to subtract 2 from both sides. Now I'm going to go ahead and divide both sides by 2. So here I get 2 is equal to b. So that is my b value, and now I can move upwards in order to solve for the original values. So here I get c is equal to negative 1 plus 2 times 2. So that tells me this is equal to 3, and now I have my c value. And now all I need to find is my a value. So I'm going to scroll up a little bit all the way to my a, and here I'm going to plug it in. So I get a is equal to 1 plus 3 times 2 minus 2 times 3. So this is equal to 1 plus 6 minus 6, which is equal to 1. So now I have all of my terms. I have a is equal to 1, c is equal to 3, and b is equal to 2. And those are the terms I need in order for that entire function. If I go back to the original question, this makes f of x continuous. So let me write that out. And there we are. That is how we figure out that entire problem. Let's go ahead and move on to problem 6. Here we have a nice little limit. So the limit as h approaches 0 of 6 plus h quantity squared minus 36 all over h. So our denominator goes to 0 when we use direct substitution. So I'm just going to go ahead and multiply out the numerator. I'm going to go ahead and combine like terms, and I'm going to cancel. So that 36 minus 36 cancels, and then the 6h plus 6h combine. So here I can see I can factor out an h. If I do that in the numerator, I pull out an h and I'm left with 12 plus h. And then the denominator, I just have an h. So here I can see my h's, which was my issue. It divides out. And now I have the limit as h approaches 0 of 12 plus h. Now I can go ahead and use direct substitution. When I do that, I drop the limit and I get 12 plus 0, which is just equal to 12. And that's our entire limit value. So typically what we want is our issue to disappear. Usually we could try to make it divide out. We have one more problem, problem 7. So given that our function is bounded, it's bounded below by 7x and it's bounded above by 3x squared, we want to evaluate the limit as x approaches 2 of f of x. So we're going to actually use the squeeze theorem. They already gave us the bounds, and I'm going to take the limit of every single part. On the lower and the upper bound, we can go ahead and use direct substitution. So I get 7 times 2 on the lower bound, which is equal to 14. And on the upper bound, I get 3 times 2 squared plus 2. So I get 3 times 4, which is 12. 12 plus 2 is 14. And that tells me how I'm bounded. So since I'm bounded below and above by 14, that means my function has to equal 14. So this entire limit is equal to 14. And this is, again, another application of the squeeze theorem. So that's all I have for us today. If you guys have more problems you want me to do, just let me know. Put it in the comments. Otherwise, if you enjoyed this video, please leave a thumbs up. And thank you so much for watching.